Good morning, everyone. I have the pleasure to start the day on this stage. I'm glad that you made it out of bed, that you're already here. I have the pleasure of introducing you to a few novelties in SimpleX. Well, SimpleX, very in just one word, is a private messenger, but I will take you through what makes it particularly private. So, since Edward Snowden, or thanks to Edward Snowden, we enjoy an internet which is now encrypted by default, or at least predominantly. But end-to-end encryption doesn't do. So this cite from Michael Hayden, the former NSA director, says we kill people based on metadata. So we should be aware that just encrypting the content is really not enough. Something is strange with the mic, I think. Okay. We leave traces at what time we talk to whom, at what time we are active online, and this is a problem that SimpleX takes seriously, and I will show you how. But there's another thing that I would like to highlight here in this talk, and that's, I do it with another cite from Eric Hughes, that code alone doesn't cut it. So we need a measure of toleration in society for activities conducted in private. This is necessary, and I mean, to say it in different terms, if we want privacy to work, it should be the default for everybody. If it's the default for everybody, it means it has to grow right now. If it should grow, it should be profitable to do privacy stuff and to maintain infrastructure that helps privacy. That should be profitable. And for this to work in the end, it should all be legal. So, how does SimpleX messaging work? I won't go very deep here, but I just want you to understand what is different from other messengers. So the SMP messaging has one very important property which you might find confusing in the beginning. There is no identity. You have no single identity in this network. You have identities for each single connection that you have. So for everybody that you talk to, you have a different identifier. And you can own the network. It is based on relay servers, which help the asynchronity. So you can post messages and the receiver can fetch them later. And everybody can run those servers. But the important thing, let me walk you through how a connection is established. So first, you create a link, an identifier. You build a mailbox for someone. Let's say I meet Alice, and I want to start chatting, establish a channel with her. I will set up a mailbox on some relay of my choice, and then I will tell Alice out of band where that is. And then she can initiate a key exchange by sending me a message into that mailbox and tell me the particulars of the channel that she establishes for me to send messages to. So this is why SimpleX is really a simplex, not a duplex channel. You have a different channel for each direction of the communication, and they are unlinkable in terms. So for the network, it just looks like two messages go from I don't know where to I don't know where. And there's no link that either the relays see or that a network observer sees. But on the network, I need to say, SimpleX also does onion routing, so we use multiple hops through relays Because if you ask one relay, what are the messages that are waiting for me, obviously you're leaking your IP address unless you use some additional layer of onion routing. But this is, so I hope I can give you this as a takeaway understanding that the main thing here is really there is no permanent identity for you. There is no link between what you send and what you receive. And it goes further than that, because you might be surprised, but many private messengers, they don't actually encrypt all the media that you send over those channels. So whatever messenger you use, please check on those facts. And SimpleX really goes a long way to also ensure that whatever media you want to send, attachments, links, or whatever, that stays private as well. And just as a brief idea how it works, you're basically chunking your file into chunks of equal size. You end-to-end encrypt them, you sprinkle them all over the network, and then you send out of band, you send a digest to the receiver who can then fetch all that from all those chunks and reassemble them. I omitted the onion routing here in this graph because it would be very complicated and harder to understand. On this slide, I don't want to bash any other messengers out there. I think the important thing is rather that we talk about what the properties are that we're interested in. So message padding is what makes a network observer see same size packets on the network. So you don't know if this is actually text that someone writes, if it is a reaction, if it is whatever, you cannot distinguish. Repudiation or deniability is a property that says if you send a message, there is no way to cryptographically prove that you were the sender. Now this might be counterintuitive, because, I mean, usually you want authenticity, and so that's why you want to see the signature that someone was sending you this message, and that they cannot deny. But in terms, if we talk about a chat, the property is actually misleading, because if you send messages of just a few words, if you had non-repudiation, if you could not deny sending them, the problem is you can cite them out of context and you have digital signatures for this. So you could just pick and shuffle and take those messages and assemble something which has a digital signature, but it's not at all what the person has said. Forward secrecy and break and recovery, that's two sides of the story. One protects the past, the other protects the future. And break and recovery, you might think that Signal has it. I think they claim that they have it, but the problem is that the way they solved multi-device support actually undermines that. Two-factor key exchange, that's how do we set up this out-of-band link to establish a communication, and there is a post-quantum hybrid crypto. So if you're really interested in all this, in these technicalities, I suggest you check our page where we have like tons of references to papers who go into depth on those X's and ticks and. Yeah. One new thing in SimpleX now is channels. You know, as I explained to you with those channels, if you have large groups, that actually means you have an eventually fully connected graph, and that doesn't scale nice. So if you want to have large groups, your mobile phone will be very busy sending all those messages to all the members of the group. This is now solved, and the way how SimpleX solves that is a group can choose kind of rebroadcaster nodes. So what is actually live now as a product is broadcast. It's not yet a group where everybody can post. That will come soon. But A in this diagram can broadcast messages to many recipients, and there will just be nodes that will take care of the distribution of the fan out. A note on governance. So SimpleX has been invented in 2020. It was just a protocol. Now it is a company. So it's one company basically developing it, doing all the, making sure, identifying who runs the servers and so on. The goal in the end is to surrender power because SimpleX wants to become a standard. Now the big question here, and that's why this timeline matters, is when is the right time to decentralize? When is the right time to give up power? Because if you do it too early, then no one really takes ownership of something which isn't relevant yet. And if you do it too late, you might already be corrupted by the power that you have. So it's a balance that needs consideration. The next step towards decentralization happened this year. So the SimpleX Network Consortium is a foundation and has been established. And the eventual next step could be some form of exit to community of DAO or whatever, but this is not yet defined, how that will look like. I promised you I will talk about profitability. Now, who should actually pay for this service, for this infrastructure? We have messaging, peer-to-peer messaging among people is something which you won't find people to pay for this. It doesn't work. So there is no kind of scale that would make it such that people would pay just for sending messages with their friends. So that will not fund our network. And that's why this will be free forever. The channels, however, I mean, imagine what we could do with channels. I mean, what comes to mind is paywalled content delivery. So you could have some publisher who wants to earn money on the content they publish. And so the power law defines, or if you look at those kinds of use cases, there is a very, very small number of channels or broadcasters who will make most of the traffic and cause most of the load on the infrastructure. And that's what we're targeting. So that's the ones that we want to pay for the network. Now, how should we do that? SimpleX is really careful about your privacy, end-to-end encryption, about metadata. So if we introduce a payment channel, we should not weaken those properties in any way. And then comes the question, well, if we can pay privately, how will that be legal? And there's actually a nice setup here, and it's a simplification, because what we need is not private payments between arbitrary members. What we need is who runs infrastructure, who builds the stuff, needs to be paid. And those can be identified. So we know exactly who the ultimate beneficiaries of those payments should be. And that makes it a closed loop system. That makes it legal to have private ways until those exits. Because on the exit to the beneficiary, it will all be transparent. And how does that actually work? So we have developed a concept which is based on blockchain payments with ZK. So the idea is you have a smart contract and you can purchase vouchers. That voucher will allow you, so you deposit some stablecoin, some other tokens, you purchased a voucher, and then you have that in your SimpleX app. And I just want to, so that you understand the UX of this. This entry step could also be credit card payments through an agent or whatever. And the SimpleX app will not be a wallet. So the users do not need to interact with the chain, because the relays will be the paymasters. So just to frame you when I walk you through now. So you bought a voucher or credits, then you assign them to a community. This could be, a community could be the publisher that you're interested in, so that has a paywall. And then that publisher can then use those funds that people assign to them to pay the relays, to pay the infrastructure that they are using. And they can then redeem on-chain. So every step needs to send a ZK proof to the chain, but there will be nothing to see that makes the parties linkable. But the final step will be transparent in the sense of, you know, which beneficiary gets how much. And then there is again a smart contract who will distribute the funds. So a portion goes to the relay operators running the servers, a portion goes to the software developers and to protocol governance, the foundation. We actually built a POC, and this POC, proof of concept, is on Polkadot. So a big thanks here first to the team at Parity who helped us. That was really a valuable input. To walk you through how it works, it's EVM smart contracts on Polkadot Asset Hub using the Revive palette. So there you buy vouchers with stablecoin. Then we have a tornado-style Merkle tree there, which we maintain. The ZK proving system is Graph 16 with Poseidon hashes. So why did we pick that? I mean, I know there are some ZK knowledgeable people here. Our goal was, so proving has to happen on the mobile. And if we want second or sub-second proving time, then Graph 16 turned out to be our choice to do so. And then we can use the SimpleX onion routing to send those proofs to a paymaster who will then submit the proofs ultimately to the chain. And that's an important forward actually, because if the user would need to pay the fees directly on the chain, that's not only an inconvenience, it also leaks information about that user. Now, for the proof of concept, I'd like to give you just the rough results. So the full flow from purchase to assigning to redemption and withdrawal was 11 cents at today's dot rates. So it is, this might not be the right measure actually, because, I mean, yeah, well, let's see what happens to the dot price. But another way to look at it is how many full flows would fit 1-2 second block on Polkadot Asset Hub, and that's 42. So that gives us an idea of how much congestion SimpleX would cause, depending on how many such flows will happen. So yeah, this is the proof of concept, and just today I may announce that we published the draft white paper of what I just presented, so please go there and give us feedback. I want to emphasize it is a draft, it has rough edges, but we're really looking for feedback. Then I want to leave you with some optimism here. This is the adoption curve of SimpleX. This little edge here in the middle is interesting. That's when a few large Telegram channels tried to migrate to SimpleX. And it didn't have the channel feature yet. So it was it was quite a mess, and it didn't really work because the groups were just too big. Now that we have the channels, the journey can continue.